This is a galaxy, a collection of stars orbiting around a common center. Now, if I asked you what makes all these stars spin around each other like that, you'd probably say, well, it's gravity, of course. Just like the sun's gravity keeps Earth in orbit. But, sorry to tell you, that answer is wrong. What actually holds these stars together isn't just gravity between them. It's something much stranger. Something we humans barely know anything about. It's called dark matter. Now hold on, why do planets orbit the sun anyway? Don't just say gravity, why do they actually orbit? Not fall into the sun and not fly off into space. Let's break it down. Imagine this is the sun and this is planet X. Obviously the sun pulls on the planet, so if you just let go of the planet, it will fall into the sun. Now if you give the planet some speed before releasing it, it'll still fall. But it will take longer. Give it even more speed and it takes even longer. And if you give it too much speed, the planet escapes the sun's gravity entirely. But if the speed is just right, it won't fall and won't fly away. It will orbit the sun. That's how orbits form, a perfect balance between gravitational pull and centrifugal force from motion. Now, is there one specific speed for an orbit to happen? No. The farther a planet is from the sun, the slower it needs to move to stay in orbit, because gravity weakens with distance. That's why Mercury, the closest planet to the sun, moves faster than Venus, which moves faster than Earth, and so on. This all matches what we know from gravitational theories, and we expect it to apply everywhere in the universe. But here's the twist. When we looked at other galaxies, we noticed something really strange. We expected the same rules to apply. Most of the galaxy's mass should be concentrated at the center, so stars near the center should orbit faster. Stars far from the center should orbit slower. But that's not what we observed. Stars far from the center were moving just as fast as the ones near the center. That doesn't make sense. At those speeds, those stars should fly off into space. The galaxy's gravity shouldn't be strong enough to hold them. So what's holding them together? This leaves us with two terrifying possibilities. Our physics is broken. We need to rethink gravity completely. Or there's a massive amount of invisible matter spread across the galaxy, not just in the center, but wait, we can see the stars in the center. It's the brightest, densest part. That's where the mass should be, right? Turns out, wrong. It seems most of the galaxy's mass is made of something we can't see at all. Not because it's just dark, but because it gives off no light, no radiation, no signal whatsoever. The only reason we even suspect it's there is because of its gravitational pull. And when we calculate how strong that gravity must be, we realize the stars we see make up less than 10% of the galaxy's mass. Over 90% is this unknown matter. Still don't believe it? Okay, let's go even bigger. Galaxy clusters. Just like planets orbit stars and stars form galaxies, galaxies also group together into clusters orbiting a common center. And again, the speeds of these galaxies make no sense. Even accounting for the massive clouds of gas between them, the galaxies are moving too fast to be held together by visible matter. Unless, again, there's more mass that we can't see. The only explanation? Dark matter. A strange form of matter whose mass is enough to hold stars inside galaxies and galaxies inside clusters. Now, what exactly is dark matter? In short, it doesn't interact with any of the four known fundamental forces except gravity. It doesn't emit or absorb light, or any form of electromagnetic radiation. We can't touch it or interact with it directly. Our only clue to its existence is its gravitational effect. Dark matter makes up about 27% of the universe. Normal matter, the stuff that makes you, me, stars, and planets, only accounts for 5%. So, where's the rest? That would be dark energy, but that's a whole other topic. Now I know what you're thinking. Come on, Roshni, this is nonsense. Just because we can't explain something doesn't mean we should invent some invisible stuff to make our math work. And you'd be right to think that. In fact, some scientists do believe our theory of gravity might be wrong. Just like Newton's theory was incomplete until Einstein came along. And yes, researchers have tried to tweak our equations to explain these weird observations without needing dark matter. Some attempts even worked, but only for specific cases. None of these new theories could explain all the phenomena at once. So for now, dark matter remains the best explanation we have. One of the strongest pieces of evidence comes from a massive galaxy cluster called the Bullet Cluster. It's actually two clusters that collided in the past. Now, when two galaxy clusters collide, the galaxies pass through each other because space is mostly empty. But the gas clouds, which are much more spread out, do collide. In this case, the galaxies kept moving forward. The gas clouds collided, slowed down, and got stuck in the middle. Now here's the weird part. When scientists measured the distribution of mass in the aftermath, they expected the most mass to be in the middle, where the gas is. But the opposite was true. Most of the mass was with the galaxies that passed through, not with the gas. How do we measure this? Two ways. One, by observation, we estimate the mass of the gas and galaxies from what we see. Two, by gravity, using something called gravitational lensing. Gravitational lensing happens when a massive object bends space-time, distorting the light from galaxies behind it. By analyzing how the light is bent, we can map out where the mass is, regardless of whether we can see that mass or not. And guess what? Gravitational lensing showed that most of the mass was around the galaxies, not the gas, even though gas makes up 90% of the visible matter. That means there's invisible mass that passed through with the galaxies, dark matter. And if our gravity theories were wrong, you'd expect the mass to still be concentrated with the gas, not the galaxies. So, what is dark matter made of? We don't know, but there are a few ideas. One, black holes? Maybe. But we'd have seen more signs of them. Some suggest primordial black holes. Tiny black holes formed just after the Big Bang, but there's no evidence for them yet. Two, particles? Maybe it's made of weird particles, like WIMPs or axions, that don't interact with normal matter. These are hypothetical particles, and so far we've never detected them. Three, neutrinos? We know neutrinos exist and they hardly interact with anything, but they're way too light to make up all the dark matter. In conclusion, we still don't know what dark matter is. It might be particles, it might be black holes, it might be a flaw in our physics, but one thing's clear, there's something out there making up most of the matter in the universe, and we have no idea what it is, which is kind of terrifying, but also humbling, because just when we think we understand the universe, it reminds us, we still know almost nothing, and that's it. This was my first long video in a while, and I hope you enjoyed it. If you want more content like this, your support really helps. Like, share, subscribe, and send this to your friends. And don't forget to follow me on TikTok. I post lots of short content there that I can't fit on YouTube Shorts. See you in the next video. Peace.